I want to take a minute to just kind of show a little bit about the sensors that we worked with in the lab last night. We worked with the reflective sensor. That was the sensor that came by default in that first scene and second scene, the scene A to B. And what we saw last night was the sensor was kind of acting opposite of what we were expecting, or at least I had kind of put a normally closed contact, and I unfortunately had made the wrong assumption myself. I didn't realize, and then because didn't quite test it before. And the reason for that is kind of simple, actually, when we start to think about this kind of logically, and that is just understanding, these sensors themselves and how they behave. So a reflective sensor. So these are all discrete sensors. And some of you are in the industrial electronics class, and we discussed these sensors in that class. So here we get to see them in operation. But the reflective sensor is a sensor that it's a light beam, and it gets sent out, and it bounces off a reflector and comes back. Being that it bounces off the reflector and comes back, then the sensor is actually kind of, shall we say, triggered. It sees the light beam coming back, so therefore it sees its reflection, and it's saying, "Hey, I'm triggered." And it works in a manner where when the reflection does not come back, then the sensor basically gets, it's off. The sensor goes off essentially. So basically, it's always on as long as the light beam is properly coming back. Then it's always on, and then when the light beam gets broken, then the sensor gets turned off. So it kind of worked a little bit opposite of what we might have expected there, kind of from what our intuition might have told us. But there are two other types of discrete sensors that we could have potentially used in this scene were available in Factory I/O. When you go to the Factory I/O, we see sensors, and here are all the available sensors to the few different types. So there were two proximity sensors that we could have picked from. There was this capacitive sensor and this inductive sensor. And again, kind of crossing over into the industrial electronics class, we learned about the inductive sensor being that it's looking for something metallic. It's going to, an electromagnetic induction based on some chunk of metal passing in front of it. So these boxes in our scenes was plastic. So an inductive proximity sensor would not have worked for us in this application. So the other one that we could have considered is the capacitive proximity sensor. The capacitive proximity sensor can detect other types of material, not just metal. It can trigger on plastic or cardboard or wood. It just sees, through its, it just sees the capacitance of an object as it's crossing versus when nothing's there, and it can trigger. So we could use that sensor. The third type we show here is a diffuse sensor. So the diffuse sensor is similar to the reflective sensor in that it's a light beam. The difference is that there's no reflector. So in this case, the light beam is getting sent out, but it has to bounce off of an object to come back. So the light beam will have to bounce, off of the box. So when the box crosses its path, the light beam will have something to bounce back off of, and that's when it gets triggered. So when it sees the light beam come back to it, like a boomerang, when it sees the light beam come back, that's when the sensor activates because it sees its light beam come back. So the diffuse sensor is nice in that we don't have to have a reflector, but we do have to kind of consider the material that the sensor is bouncing the light off of. If the material isn't really very reflective, then it may not properly sense that object. Now, one of the things that was kind of nice to see, if you were kind of setting up these scenes, we see these, I'm in the offline mode right now. We see these red dashed lines going out. So this is actually indicating the sensing distance or depth of that it can sense. So in this example of the capacitive sensor, we can see that it's not a very far distance. This is actually the maximum sensing distance for this device. So if I kind of just click on it to activate it, I can see that I can actually adjust its sensing distance. But this is as far as it goes, just a matter of a few inches out from the sensor. Whereas our light sensors have the ability to go further out as well as dial it back in. So this one I just had kind of triggering across the entire beam, or I'm sorry, the entire conveyor. And the same thing with the reflective sensor. I could actually take this reflector and move it further back, and we can get several feet. So we get a pretty decent distance with reflective sensors. Diffuse sensor would be, as you saw, it kind of capped out about right there. So it, you do get a decent distance, but there is a cap to it. Whereas the reflective sensor can go a much further distance for that light beam. So this is just the, so I'm going to show you how this operates. We've got the conveyor. This is basically the same conveyor we were messing with in the lab last night. We've got the box, we've got the conveyor motor. And then what I have going on up here is I can actually look at the values of these sensors and actuators too in this little kind of watch window up here. I can just drag them up here, and then I can actually force the conveyor belt on just by clicking on it. So I can kind of totally test this without having to be connected to a PLC. I do need to be in the run mode for this. One other thing to note is I did slow down the speed of the simulation just to kind of help show this a little better. So I've slowed it down half speed at the moment just to kind of let it run a little bit slower. So when I go in the run mode, I'm going to go ahead and force on the conveyor in just one moment. I want to show that what's happening here is I got this kind of lit up orange indicator next to the reflective sensor, and you can see how it is colored yellow here too. So it is considering that the light, that the reflective sensor is true or made right now. It's on. Again, it's going to go off when the beam gets broken. One other thing to show you is there are some indicating lights on these sensors, which obviously are very hard to see when you're not zoomed in. But we have a green and a yellow light here. So one of these is telling us that the sensor is aligned. The green LED is saying that it's aligned. So basically, it's just saying, hey, I've got I'm aligned with the reflector. And the yellow one is saying that the light beam is not interrupted. So when the yellow light is on, it is the beam is getting reflected back, basically. The capacitive sensor doesn't necessarily have an indicator on it, and then the diffuse sensor does have a little LED on top of it that would light up when it gets triggered. Right now, it's not triggered, of course. So we are in the run mode. I'm going to go ahead and force the conveyor on. So we got you can see our belt is rotating. We're going to see our box come into the scene here in just a second. And I'm going to go ahead and pause it, so I can actually pause this, and we'll see that here we are: the diffuse sensor, capacitive sensor, reflective sensor. So I'm just going to go ahead and unpause it, and we can see now that LED went yellow. Went red to indicate that it triggered. We can also see that the diffuse sensor turned orange. So it is now considered on, true. I'm going to unpause this, let it get to the capacitive sensor. So now we can see the capacitive sensor has triggered, it is on, therefore it's true, indicating to the box that there's something is in its presence, basically. Now the back of this box has cleared the diffuse sensor, so it has turned off. And the reflective sensor now has gotten triggered. You can see we can't see the reflector any longer. And now it is basically dropped off, out or off. So now we're past the capacitive sensor, so it has turned off, back to off. And then if I go ahead and complete this box off of the table, we see now that the reflective sensor basically turned back on because nothing's breaking the light beam again. So I hope that kind of helps explain why we had to do what we did with the contacts last night and how these behave. It all came down to the fact that the reflective sensor, being that the light beam is bouncing back, is basically saying that, hey, I see the light beam, therefore I'm active or I'm on. And then it has to be where the light beam is no longer reflected back. And then that's when it, shall we say, triggers, in this case, turns off. So there are a few other sensors here that we could consider in the application. There's a vision sensor. This is a camera, so it's kind of be a more high-tech sensor we need for this type of detection. There's also these light arrays, which if I were to put one in here, you'll see that this is more like a light curtain. So it's an array of light that would line up to a receiver module on this end. And basically, if anything breaks, any one of these beams get broken, even the top one only or the bottom one only or any in the middle, then it would trigger this whole light array. So this would be designed, this would be more for like a larger application, like a larger box or something. They can measure, something breaking or the presence of like a person walking through this light curtain light array. So we wouldn't really use this for this application either. It's just a little bit larger than we would need. So our 3 sensors down here could potentially do the job for us. All right, that was it. Just wanted to give a little, just wanted to kind of help show that a little better, and maybe that helps visualize how these sensors operate for you as well.